Graphing rational functions, we have to set up parameters, and what these parameters are holes in our graph, which is a common factor top and bottom. So if you factor everything, you have a common factor, you have a hole in your graph. Vertical asymptotes, they're factors of the denominator only. When the denominator equals 0 at a specific place, the graph cannot exist. Horizontal asymptotes is when we're comparing the coefficients of the top and bottom when you have a common degree. And let me show you those horizontal asymptotes. 3 things can happen. So let me give you an example. The first one, 3x squared plus x over x squared minus 1. So because my degrees are the same, all I do is compare the coefficients in the front. Horizontal is a y equals, so y equals 3 over 1 or y equals 3 would be my horizontal asymptote. Well, what happens when I have x over x squared minus 1? Those are not the same coefficients. So what I'm going to do is I'm going to add one. I'm going to add a 0x squared. Well, 0x squared is, it's non-existent, so 0 times x squared. But now that they're the same degrees, I can compare them. Y equals 0 over 1. When I simplify that, I get y equals 0. Well, let's try one more. Suppose I have a bigger one on the top. So x to the third plus 1 over x squared minus 1. As of right now, I cannot compare them because that's a 3 and that's a 2. So on the bottom, let's add a 0x to the third. Now I can compare this one with this one. So I have y equals 1 over 0. Well, 1 over 0 is undefined, so I would have no horizontal asymptotes. Let's check for holes in asymptotes. The first thing I'm going to do is I'm going to factor. On the top, I have x minus 4 and x plus 1. On the bottom, I have x minus 4. So the first thing I can look at is, do I have a hole in my graph? And I do. The factor x minus 4 is a hole, which means I take that factor, set it equal to 0, and the hole in this graph happens at x equals 4. Vertical asymptotes. I look for the remaining factors in the denominator, and since I don't have any, I have no vertical asymptotes. Horizontal asymptotes. Those compare the degree. So I'm going to go back to the original one in white. I'm comparing this degree with this degree. They're not the same, so I'm going to add a plus 0x squared to the bottom, and now they're the same. So I'm comparing the coefficients. Y equals 1 over 0, which means, again, that's undefined, so I have no horizontal asymptotes. So all I have in this graph is a hole. If I was to graph it on my calculator at x equals 4, wherever this graph would happen would have a hole right there. And then it looks like it's going to look something like this. I'd put this in my graphing calculator, or I could just go ahead and graph the remaining pieces right there. Next example. I'm going to start by doing the same thing. I'm going to factor the bottom, and when I factor the bottom, I get x minus 2 and x minus 3. And if you don't remember how to factor, it's multiples of 6, 1 and 6, 2 and 3, and I read it backwards, that add to give me a negative 5. So those would add to give me a negative 5. So let's start with a hole in our graph. When I'm looking at a hole in my graph, I'm looking for a common factor top and bottom, and since I don't have a common factor, I have no holes. The next, vertical asymptote. Vertical asymptote comes from the factors of the bottom. So I'm going to take x minus 2 equals 0 and x minus 3 equals 0. When I solve, I get x equals 2, there's one vertical asymptote, and x equals 3, there's the second. Well, what does that look like? When I graph at 2, I put an imaginary line and label it x equals 2. My graph is not going to touch that. And at 3, x equals 3, I'm going to put an imaginary line through it. The next piece, horizontal asymptotes. I'm going to go back to the original and I'm going to compare my degrees. So in this case, I need to add a plus 0x squared to the top, and now I'm comparing. So y equals 0 over 1, which means y equals 0. So at this line right here is an asymptote. Now I would plug it into my calculator to figure out what my graph is going to look like. So when I plug it in, it's going to come close to these asymptotes here but never touch those lines, and do the same thing over here.